Hello, this is lesson 1.2 explainer. We're going to be going over velocity, acceleration, and displacement. David is driving a steady 30 meters per second when he passes Tina, who is sitting in her car at rest. Tina begins to accelerate at a steady 2 meters per second squared at the instant David passes. How far does Tina drive before passing David? Our concepts are velocity, acceleration, time, and displacement. Velocity, the directional speed of an object. Acceleration, the change in velocity. And displacement is the vector difference in position or change in position. So here I drew out basically what's happening. We see that David's going at a constant velocity, 30 meters per second. So his arrows are all equal. While Tina, she's accelerating from 0. So she's getting her velocity is getting bigger. Her vector is getting larger, and we're trying to find out the distance it takes for us to get here. The second Tina passes a David, we're gonna say that is x. So to make this simple, we're gonna find all our knowns and our unknowns. For David, we know his velocity is 30 because he's at a constant velocity, and his change in distance is equal to x, change in t, which is equal to t. For Tina, we know her initial velocity, which is equal to 0. We don't know her final velocity, it's an unknown, and her acceleration is equal to 2 meters per second squared. We don't know her change in position, which is equal to x, and her change in time, which is equal to t. So we see our unknowns and our knowns, and what we're trying to find is our change in distance. For someone with a constant velocity, we can use an equation that is equal to velocity times time. So change in d is equal to 30 times t. So change in d is equal to 30t. For Tina, we can use one of our kinematic equations right here, and we're going to use the third one here, which is change in d is equal to VIT plus 1/2 AT, initial velocity, times t, so 1/2 acceleration. So change in d is equal to VIT plus 1/2 AT squared. And we know acceleration is 2, so 1/2 of that is going to be 1. So, and our initial velocity is 0, so this would cancel out. So our change in d is going to equal t squared. So obviously we got our 2t's, so we can set our change in directions equal to each other. Change in direction, so 30t is equal to t squared, and we can subtract that t, and then we can factor t times 30, t minus 30, so t times t minus 30, so t will either be equal to 0 or t will be equal to 30. And obviously we didn't only go 0 meters, so we're going to say it's 30, and we can plug that back into either one. So we're going to do it into the easier one, obviously. So velocity is 30 times the change in time, which is 30 seconds. So we found that the change in distance is equal to 900 meters. So this is how far it took before Tina passes the David. To fact check it, we can also go back to Tina, and we can just go ahead and do initial velocity 0 times 30 plus 1/2 2 times 30 squared, which is equal to 0 plus 1 times 900, which is equal to 900. So our final answer is 900 meters traveled before Tina passes David.